course, I would like to thank Anne-Marie and also Lévis and Daniel for this organization and for having me. So I'm Sylvain Delplanque, and I work at the Swiss Center for Affective Science in Switzerland, in Geneva. And with this presentation today, I would like to introduce neuroergonomic researchers who are not yet sensitive to the problem of what we call reverse inference. And I think it's an important issue since this discipline uses a large number of measures, physiological, brain, and so on. So to begin with, we can ask ourselves, what do we measure when we measure emotions? Emotions do not happen by chance, they do not occur erratically, and they are not useless. In fact, understanding the determinants of the nature and the functions of emotion has been the object of research programs in most of the academic disciplines interested in the mind, the brain, or the behavior. And for some disciplines, but not for others, understanding goes hand in hand with measuring. For instance, in psychology, neuroscience, and affective computing, most research traditions involve measuring emotions in one way or another. So the quantity and quality of tools that have been developed to try to measure emotions have exploded in the past 20 years. And researchers in neuroergonomics are users and also developers of these techniques. So we can increase our understanding of emotion by measuring some key variables in laboratory settings or in everyday life. But once measures are associated with emotion, we may think that one can go backwards from measure to emotions. The question is, based on some measures, can we automatically detect specific ongoing emotions, even without asking the person what she or he feels, for instance? So this is called the decoding question. And this decoding question is not specific to emotion. For instance, can we know whether someone is dreaming by measuring his or her electroencephalographic activity? And what about the content of the dream? Can we know whether someone is lying by measuring his or her facial expression, for instance? And in our daily social interactions, we use behavior of others to infer what they feel. We may make wrong inferences, but we spontaneously make such inferences about the emotions of others based on social and affective cues. So inferring emotions based on accessible signals is a tendency that we have both as social individuals and as scientists. And in fact, academia and industry have developed methods and devices aimed at detecting specific emotions like joy, anger, fear, disgust, or whatever. And those methods and devices based on physiological and behavioral signals. And I will try to show you why, and I will try to show you that this is currently a risky path to be taken in terms of scientific validity, and I will try to explain you why. Okay, let us start with the question raised above, and to answer this question, we need a definition of what an emotion is. And here in this talk, I adopt a view that I believe to be both consensual and of particular interest with respect to the measurement. So emotion is typically used to describe the processes taking place in a short period of time during which an individual is subject to a number of changes in 5 components of his organism. The elicitation components and 4 components of the emotional response. And those 4 components are the expression, the feeling, the autonomic psychophysiology, and action tendencies. And what triggers these changes in these components is the individual's appraisal of the importance of the stimulus with respect to his or her well-being, goals, and concerns. So let's have a look more deeply to these different components of emotion. So the first component of emotion is what we call the elicitation or the cognitive components. It's the evaluation of the situation and the determination of an emotion. And the way in which the situation is evaluated and gives rise to an emotional response is a great subject of debate in affective sciences. I don't have time to deal with these aspects. And we can measure this elicitation component through, for instance, self-report, questionnaires, as the individual is engaged in an introspection. But of course, not all the processes are conscious and available through introspection. Then it is possible to use measures like reaction time or accuracy in tasks that will specifically target an implicit process, for instance. And you can also use brain-related measures like EEG, MRI, or NIRS, as we had just talked just before, just to try to target and measure these different processes in this component. The second component is the autonomic reaction. And during an emotional episode, physiological changes allow the body to react to the demands of the situation. And the specificity of the physiological reaction during a specific emotion is very old debate too in the field, and maybe I can explain that later if I have questions. But we can measure these components using a lot of different measures like electrocardiography, electrodermal activity, but respiration, also hormonal reactions. So we have a lot of different measures to target this physiological response during an emotional episode. This motivational component is also called action tendencies. And action tendencies correspond to the state of the individual that prepare the action more or less specific to the emotion. It's, for instance, the approach in anger, the avoid in fear, or the rejection for disgust, or the submission in shame. So there are methods to measure action tendency, but they are relatively scarce as compared to other components of emotions. The next component is the expressive components, which aim at communicating the reaction and the behavioral intention. Facial, vocal, and postural emotional expression represent powerful social signal. There is a lot of battery of measures of this expressive component, like measuring action units, visible spectrum of the facial movement, electromyography, infrared thermography, and so on. And the last component, which is very important, is the feeling, which is typically conscious. It's a subjective experience of the emotion by the individual. And the measurement of this experience is mostly carried out using questionnaires with open or closed questions. And it is by far the most widely used measure of emotion because it is easy to set up and it characterizes very finely the various emotional states. It has a lot of limitation, like the difficulty for introspection, but also bias like social desirability, but it is an essential measure of the conscious part of the emotional response. Okay, so these are the 5 components that we can try to measure when we measure an emotion. What differentiates emotion from other affective phenomena, such as mood, is that emotion has a precise onset and is associated with a particular situation and is of short duration. And the key function of emotion is to quickly prepare the individual to react to the situation in an adapted manner. each component of emotion participates in this adaptive response. They all have a different function in the response. And the last point I would like to highlight inside this definition is the fact that during an emotional episode, all the components changes are organized in a more coherent manner than during non-emotional episodes. And there are recent data that show the existence of this synchronization of the different components, at least at the cerebral level. I can encourage you to go and see this paper. Okay, so as I hope I've shown you that an emotion is a complex phenomenon, and you can't reduce the emotion to only one of its components. And the differentiation of emotion on the basis of only one of these components do not reflect the complexity of the emotion. So for instance, if any putative emotional response obtained at the subjective levels needs to be associated with other response like cognitive, behavioral, or physiological to be fully considered as a true emotional response. I'm going to show you an example of the main point of my talk, which is the reverse inferences. Now you have the definition of an emotion in head. So the data were collected here in a scanner where we asked people to smell different odors, and we ask for their feeling via questionnaire, and we recorded their brain activity while they are smelling a lot of different pleasant and unpleasant odors. The research question was, can we go beyond the liking? Are there specific networks for each odor-related feelings? So this is the MRI compatible olfactometer. So it's very difficult to send a lot of odors inside the scanner. So we record the brain, but we managed to do that. And then we also have physiological responses. Okay, the results. Basically, we found that different feelings like sensory pleasure, sensuality, pleasant feeling, unpleasant feeling were associated with specific brain network in the brain, even if you remove the liking. Okay, so from a theoretical point of view, we answer our question, which was, can we go beyond liking? It worked. But my point today is more, okay, that's what we did. We asked the question, what brain activity is associated with a given experimental condition or a given reported emotional state? That's a normal forward inference. So the forward inference, here we have for instance, three different odors. Here is the response, the subjective response, and you can see a specific brain network. And for different odors, you have different feelings and different network. The question is now, if you just look at the brain network, can you infer which feeling was elicited by the stimulus? So what would be very cool is to be able to do that but it is called a reverse inference. So what cognitive behavior or process or emotional state is occurring given the brain activity? Unfortunately, it's very difficult to do that because, in fact, when you look at brain activities, specific brain activity in different regions, they are not associated with only one process, very rarely. So it's only true if only the specific mental process is a result in the activation of a specific region of interest. And this reverse inference that you can't do is the case also for every component of the emotion. Let's take another example with physiological measures. So in this experiment, we just provided the participants with very unpleasant smell and very pleasant smell, and we measured the subjective reaction with scales like liking, for instance, arousal, and the physiology with electrocardiography, heart rate, electrodermal activity. So this is unpleasant smell, like rotten, rancid butter, or sweat, body odor, or even skunk, and very pleasant odor here. And here is how the results, as you can see, you have the subjective ratings. You have very big differences between pleasant and unpleasant odors in terms of valence, which is just a check. And you also have differences in the skin conductance responses, and you have differences in the heart rate. The heart rate decreasing as the odor pleasantness increase. The more pleasant the odor, the more important the decrease in heart rate. Okay, that's forward inference. That's the normal way of thinking. So pleasant odor induce a decrease in heart rate. But now, what is the reverse inference fallacy? Is to say that a product that generates smaller heart rate, for instance, and is to automatically deduce that this product is pleasant. That is the case of reverse inference fallacy. Why? Because the heart rate changes are also, and this is of many different processes, not only pleasantness, but novelty detection, orienting, attention orienting, startle or defensive reaction, or even effort. So the change in heart rate is not specific to pleasantness. This leads to a very important question of what we call what can we have as inferences from measure. The important question is whether some measures are more informative than others. For instance, we can call the measure a concomitant or a marker, and people are using biomarker or neuromarker always without asking this question. The question is, what are the degrees of association and specificity between any given measure and the construct emotion? Let me exemplify that. If there is one-to-one specific relation between the measure of the emotion, it means that a given emotion at a given intensity would be associated with one and only one measure or only one measurement pattern, and vice versa. And we can call that an emotional marker. I repeat, a given emotion associated with one and only one measure. And to the best of my knowledge and our knowledge, there is no such marker for any given emotion. Most of the cases, all the cases, we have what we call a many-to-one relation. What it is, it's several cognitive processes, mental phenomena, or physiological states other than emotions will affect the measurement. In that case, we call that emotional concomitance. So each central or peripheral psychophysiological measure, each behavioral measure, such as reaction time, accuracy, facial action unit, approach, avoidant movement, are correlates or concomitant of emotion. None of them is so far a marker of an emotion. Do we have a solution? I would say that we have to go beyond the simple measure and use a multi-componential approach. What is a multi-componential approach? In fact, it is adding measures of different components which will make it more possible, probable, likely to characterize existing differences between emotion. Let's take one example. If you take physiological measures to characterize fear or anger, you will probably not see any difference between your physiological measure between those two emotions. Why? Because fear and anger are both unpleasant and arousing. And physiology is really sensitive to pleasantness and arousal but you will not see differences between fear and anger. But if you add action tendencies, maybe you will be able to make the difference between the two. Why? Because fear is rather associated with avoidance. You want to avoid the situation when that is fearful. And while anger is rather associated with an approach to the situation. You want to fight, usually. And if you add other components like appraisal, you can also maybe make a difference between the two. Because in anger, for instance, the coping potential, so your ability to cope with the situation is typically high. Then in fear, you feel a bit helpless. Also, you can use the expressive component because, for instance, for a typical angry face, you will have more corrugator activity. Corrugator is a muscle which will make you frown. So you will have more of such an activity than for fearful face. And you can also ask people because they will report something like anger or fear. And I would say that, which is complex to achieve, but a given and dynamic combination of the measure could come closer to the notion of a marker. So maybe by adding many different measures with different angles and looking at those measures together, maybe we can find a pattern that is specific to an emotion. So my conclusion will be that measures of emotions are not markers of emotions. The risk is high to make wrong reverse inferences when focusing blindly on a single measure. And an increase of converging evidence can be obtained from the 5 components of emotion and will decrease these risks. A very last example, so I hope I will be even clearer. Consider an object that is supposed to be designed as interesting. So if you showed to a group of participants these objects, and participants shows an increase in skin conductance response, and also their eyebrows are lowered in the expressive components. They also show signs of approach, and they evaluate the object as unfamiliar, complex, but understandable. And they also report verbally that they feel interested. So you see there is a coherence between the outcomes of the response, and it increases the likelihood that the person really feels the emotion of interest. So I'm going to stop there. I thank you for your attention, and if you have questions, I would be happy to take them.